Researchers at Princeton have developed a new chemical reaction that breaks the strongest bond in a molecule instead of the weakest, completely reversing the norm for reactions in which bonds are evenly split to form reactive intermediates. Published on July 13 in the Journal of the American Chemical Society, the non-conventional reaction is a proof of concept that will allow chemists to access compounds that are normally off-limits to this pathway. The team used a two-component catalyst system that works in tandem to selectively activate the strongest bond in the molecule, a nitrogen-hydrogen (NH) bond, through a process known as proton-coupled electron transfer (PCET). This PCET chemistry was really interesting to us. In particular, the idea that you can use catalysts to modulate an intrinsic property of a molecule allows you to access chemical space that you couldn't otherwise, said Robert Knowles, an assistant professor of chemistry who led the research. Using PCET as a way to break strong bonds is seen in many essential biological systems, including photosynthesis and respiration, he said. Though this phenomenon is known in biological and inorganic chemistry settings, it hasn't been widely applied to making new molecules, something Knowles hopes to change. Given the unexplored state of PCET catalysis, Knowles decided to turn to theory instead of the trial and error approach usually taken by synthetic chemists in the initial stages of reaction development. Using a simple mathematical formula, the researchers calculated, for any pair of catalysts, the pair's combined effective bond strength, which is the strength of the strongest bond they could break. Because both molecules independently contribute to this value, the research team had a high degree of flexibility in designing the catalyst system.